Alright, this is lesson 3, or part 3 of lesson 1.4 on quadratic equations, and we'll be solving a quadratic equation using the quadratic formula, and then we will be evaluating the discriminant to determine the number of solutions to a quadratic equation. We've already covered completing the square, the zero product property, square root property in previous videos. Alright, so remember that a quadratic equation is in this form, standard form, ax squared plus bx plus c equals 0. And we need it in standard form to be able to take out a, b, and c to put into the quadratic formula that appears below. X equals negative b, or opposite b, some say, plus or minus the square root of b squared minus 4ac, all divided by 2a. You may have heard some songs to help remember this formula. There's one that goes to Pop Goes the Weasel. There's a great YouTube video of two teachers singing it to Adele's Rolling in the Deep. So I'm not going to do that for you because I'm not that talented. So we'll move on to solving them. Alright, so here's our first example. Solve x squared minus 4x equals negative 2. First of all, I know it's quadratic because the highest exponent is 2, also known as the degree of the equation, remember. And so I'm going to solve it using the quadratic formula, but before I do that, I need to make sure it's equal to 0. So I need to move this negative 2 over here to the left-hand side. So I've set my equation equal to 0. I am ready to identify my a, my b, and my c at this time. A is with x squared, and the coefficient with x squared is 1. So a will be equal to 1. B is with the x term, so the coefficient of x is negative 4, so our b is negative 4. And c is positive 2, always the constant. And in the case that we don't have an x term, then b would be 0. If we didn't have a c term, c would be 0. But we should always have x squared in order for it to be quadratic. So now we're just going to take these numbers and replace the letters in our quadratic formula. Okay, so I've just written the quadratic formula over here to the side so we can replace b's, a's, and c's in that. So we're going to have x equals the opposite of b. If b is currently negative 4, the opposite of that would be positive 4. So that's where I'm going to just write 4. And then our formula says plus or minus. So that's my next, plus or minus the square root. And then b is negative 4, so I do negative 4 squared. My formula says minus, so I'm going to write a minus. And it also has a 4, so I write the 4, times a and c. A is 1, and c is 2. And all of that is divided by 2 times a. So 2 times 1. Now please do notice that this fraction bar goes over the entire problem with this 4 included. Do not forget that part. So now I'm just going to do some simplifying. First I'm going to simplify what's underneath the radical alone and get it down to one single number. Okay, so here I've simplified this. Negative 4 squared is positive 16 minus 8 would leave me with 8. And so then I have 4 plus or minus the square root of 8 divided by 2 times 1, which is 2. And now I'm just going to continue to simplify all that I can. So the next thing I do is take the square root of 8 and simplify it down in radical form. So to simplify the square root of 8 here to the right, 8 is 2 times 4. And then I can take the square root of 4, which is 2. So square root of 8 is going to become 2 root 2. So then I'm going to have x equals 4 plus or minus 2 root 2 divided by 2. And now I'm going to simplify this by dividing 2 into both the 4 and the 2 here, but never into the radical. So we have x equals 2 plus or minus 1 root 2. I don't have to write the 1. And then I can leave my answer as that because I cannot simplify the root of 2 any further. Right here we have another quadratic that I need to solve. And so first of all I need to get the x and the negative 4 onto the other side with the 2x squared so that it can be equal to 0. Alright, so again, I've set it equal to 0, and I've also written the quadratic formula here to the right. So now I'm going to identify my a, my b, and my c. A is with x squared, so a is 2. B is with x, so b is negative 1. And c is the constant, which is 4. And now I just need to plug these in my formula so that I can solve this equation. The opposite of b, since b is negative 1, would be positive 1, plus or minus the square root of negative 1 squared minus 4 times a times c, all divided by 2 times a. Now I'm going to take what's underneath my radical and simplify that further. And when I do that, I get 1 plus or minus the square root of negative 31 divided by 4. And now I need to take this radical and simplify as much as I can. And so I do know that I'm going to have a complex solution because of the negative under the radical. So I take negative square root of negative 31, and I take out the I, and that leaves me with I root 31. I cannot do anything to 31 any further than that. So then my answer is going to be x equals 1 plus or minus I root 31 over 4. And to write this in standard form, I would just write it as x equals 1/4, which is giving the 4 here. And then I root 31 over 4. So plus or minus I root 31 over 4. And then sometimes you'll see, instead of writing the I here, they'll write it in the back. But this is a fine for the solution for me. Final answer. Okay, and the last thing we need to discuss here is the discriminant, which is part of the quadratic formula. And so our discriminant is just the part that is underneath the radical symbol, what you see in blue here, b squared minus 4ac. And we use that to determine the number of solutions that we have and what type of solutions those are. All right, this chart gives us the number of solutions and type depending on what you get for your discriminant. So if I have a discriminant that is positive and a perfect square, so 4, because 4 is a perfect square, 2 times 2, or 49, 7 times 7, then I have 2 solutions and they are rational. If I have positive but it's not a perfect square, 1's a perfect square, but 3 or 5, then the number of solutions is also 2, but it's an irrational solution. If I get a discriminant of 0, I have 1 solution, which is sometimes referred to a double solution, and because it's the same number twice, and I have that type is rational. But if I get a negative discriminant, I know I have 2 solutions that are non-real complex solutions, the ones like we just found in the last example. Very important for you to know this chart and have it. Okay, so in these last few examples, we just want to evaluate the discriminant for each part. So this is already in standard form. I know my A, my B, and my C. Here is B, 2, and here's A and C. And the discriminant is b squared minus 4ac. So I'm just going to substitute my numbers into the formula, and that gives me 2 squared minus 4 times 5 times negative 4, and I get 84 for the value of the discriminant. Now since 84 is positive but it's not a perfect square, there are 2 distinct irrational solutions. We're going to evaluate the discriminant for this quadratic. This is x squared minus 10x plus 25. And so now I'm going to identify my A, my B, and my C. A is 1, B is negative 10, and C is 25. So evaluating the discriminant, b squared minus 4ac, I get negative 10 squared minus 4 times A times C, which gives me a value of the discriminant which is 0, and that means that there is one distinct rational solution. And our last example, determining the number of solutions using a discriminant. Here's A, B is negative 1, and C is 1. B squared minus 4AC is our discriminant. So I have negative 1 squared minus 4 times 2 times 1. And when I evaluate that, I get a value of negative 7 for my discriminant. And since I get a negative value, there are two distinct non-real complex solutions. Okay, and so that concludes our video for tonight. I do have a joke for you because I know my last couple videos have been kind of dry and I haven't done a very good job of making them very exciting. Not that this joke is going to do that for you, but we'll see. And it's Halloween joke since Halloween's coming up next week. What do witches get in hotels? Wait for it. Wait for it. Broom service. Okay, I got one more. Hold on just a second. Alright, one more for you. What do birds do on Halloween? Wait for it. They go trick-or-treating. I know, those were great jokes. See you tomorrow.